Welcome to Chapter 2. Chapter 2 is all about sequences and equivalents. The first half of the chapter is going to be all about sequences. So what we're going to be talking about today is representing exponential growth. So now, you can kind of read through in the Book of Mice and Men by John Steinbeck, and you'll probably read that your junior or senior years of high school. I think that's when I read it. So we're going to be talking about the number of rabbits we would have. So we're starting off with 2 rabbits, and those 2 rabbits have 2 babies after 1 month, and then those 2 rabbits have 2 babies, and so forth and so on. So determine the number of rabbits that we have. So what I'm going to use as my key is we're going to make a sketch, and it's going to get pretty weird pretty quick. So we have open dots. Those are going to represent the parents, and X's are going to represent the offspring. So now, in month 0, we're going to have just the 2 parent rabbits. We just have 2 rabbits in month 0. Now, in month 1, we have 4 rabbits. Those 2 parents had 2 offspring. In month 2, now the 2 initial parents have 2 offspring again, and the original offspring now have 2 offspring of their own. In month 3, the initial parents have offspring again, and now the offspring have their own 2. The other pair of offspring have another 2, and another pair of offspring have another 2. You can see how fast this is growing. Month 4, you can see we have 1, 2, 3, 4, 5, 6, 7, 8 sets of parent rabbits, and those 8 are going to have their own offspring. Seven and 8. Now, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sets of now parent rabbits having offspring. So we're going to have a whole lot of rabbits. Now, I'm not even going to bother trying to draw the next ones. But let's think about this as a table of values. So when X is going to be the number of months, and Y is going to be the total rabbits. Month 0, we can see we had 2 rabbits total. Month 1, we had 4 rabbits. Month 2, we have 8 rabbits. Month 3, we had 16 rabbits. Month 4, we had 32 rabbits. And hopefully you're starting to see the pattern here. To go from 2 to 4, and then 4 to 8, and then 8 to 16, and 16 to 32, what we're doing is we're multiplying by 2 each time. So we could go to month 5, and then we would have 64 rabbits. And then we'll go all the way down to month 12. So we keep doubling. 64 times 2 is 128. Times 2 is 256, and then 512, and then 1,024, 2,048, 4,096, 8,192. That's a lot of rabbits. Now that's in a perfect world where none of the rabbits pass away, but that's what we have. Now, what's happening here is we can write a rule. Now, if you think about exponents, 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8, and so forth. But those don't really match up to what we have. So we think about is when we write a rule for this, and this is kind of the whole point of this section, our rule is going to be to get these numbers to become the numbers in our table, we'd have to multiply them by 2. So our rule, y equals 2 times 2 to the x. That's our rule for this problem. Now that 2, that's our starting amount. That's our initial. And then 2 to the x, the base of that exponent, that's our multiplier. We're multiplying by 2 each time. So the total number of rabbits equals 2 times 2 to the x, where x is the number of months. All right, let's go to the next page. Now, in this case, we're starting off with 10 rabbits, and each pair is having 2 per month. So month 0, we start off with 10 rabbits. I'm going to pair them up. So then in month 1, we have 2 parents, 2 offspring. 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 Okay. Now in month 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of parents. So 2 parents, 2 offspring, that's 1. 2 parents, 2 offspring, that's 2. 3, 4, 5, 6, 7, 8, 9, 10. That's a lot of parents and offspring. I don't want to write any more of these. That's just way too much work. So x and y, same thing. X is going to be the number of months. Y is the number of rabbits. So in month 0, we had 10 rabbits. In month 1, we had 20 rabbits. In month 2, we had 40 rabbits. Now you can see we're multiplying by 2 each time again. And that's the number of rabbits that each one of these are having. So then in month 3, we would have 80 rabbits. In month 4, there would be 160 rabbits. In month 5, there's going to be 320 rabbits. It's going to just keep going and going and going. That's a lot. So we can write a rule. So it's going to be our initial amount, the starting amount, and our multiplier. Now our initial amount for this, we started with 10 rabbits, times our multiplier is 2, because it's doubling each time, to the x. That's our rule. We started with 10, and our multiplier was 2. We're doubling each month. We're adding, they're each having multiplier by 2 each month. In the next case, we start with 2, and each pair has 4 per month. Just to give it a quick sketch, here's our month 0. We start off with 2 rabbits. In month 1, they have 4 offspring. So start off with 2 rabbits and then 4 offspring. Month 2, now we have 1, 2, 3 sets. So there's 1 set, 2 sets, 3 sets. This is growing pretty quick. Then you can see in month, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not even right. 1, 2, 3, yep, 9. We have 9 sets having 4 offspring. That's going to grow even faster than the last one. So if you think about it, table, x is the number of months. Month 0, we had 2. Month 1, we have 6. Month 2, we have 18. So if you see, to go from 2 to 6 and 6 to 18, our multiplier is 3. So for month 3, we would have 54. Month 4, we would have 162. So our equation, y equals, now our initial this time is 2, But our multiplier now, we're multiplying by 3 each time, so it's times 3 to the x. Our multiplier changed for this one. Here it's not a multiplier of 2, it's a multiplier of 3. In our last case, we start with 2 rabbits. So month 0, we got 2 rabbits. Month 1, we have 6 per month. 2 parents, 6 offspring. So in month 2, we have 4 sets. Here's our first set. So one more set. That grows even faster. So looking at a table, because I don't feel like drawing any more circles and X's, month 0 we got 2. Month 1 we've got 8. Month 2, if you count them all up, you're going to have 32. To go from 2 to 8 and 8 to 32, you're multiplying by 4. So our rule, y equals 2, our initial, times our multiplier, 4 to the power of x. And that's our rule for that last case. So if you go to the next page, we're going to just be talking more about these. So if you look back at the tables that we created in problems numbers 1 and 2, what do they all have in common? All of them are being multiplied by a constant. They're all going to be like 2, y equals 2 times 2 to the x. Y equals 10 times 2 to the x. Y equals 2 times 3 to the x. And y equals 2 times 4 to the x. They're all being multiplied by a constant. And that constant is our initial number of, in this case, rabbits. It's our starting point. It's our y-intercept. Now, if you were to graph all 4 of them, and you could graph this right on a graphing calculator. So our graphs, 3 of them have the same intercept at 0, 2, and one of them has an intercept at 0, 10. Now, what's going to happen is they're just all going to have different steepnesses. And the steepest one of them all would be the one with the multiplier of 4. Y equals 2 times 4 to the x would be the steepest graph. It's got the largest multiplier. Now, is this linear? No. You can see for linear, the graph is a line. Now, this is what's called an exponential graph. An exponential, let me try to spell that again. For an exponential, it's a curve. And it's a pretty sharp curve. It's going to grow very quickly. So it's not linear. Not linear. It's exponential. And then to just talk about this and generalize, these exponentials are going to be in the form of y equals a times b to the x, where a is our initial and b is the multiplier. Later on, we're going to be talking about the general rule, where we add some extra parts to it. Nothing to worry about right now. I just want you to be informed that there is going to be some changes that are going to occur later on. And that's our introduction to exponential functions, y equals a times b to the x, where a is our initial, our y-intercept, and b is our base. and that's our multiplier. Okay, thank you.